Okay, so today we're going to talk about threat intelligence. Now, threat intelligence basically refers to how much do you know or how much do you understand about the potential attack methods out there. And it pays to have this kind of information from two different perspectives. First of all, because you need to be a good security professional, of course. You need to be kept up to date to know what's going on in the security world and how to better protect whatever you're paid to protect, right, in your company. And secondly, it also helps us to better configure, select, and even install, deploy actual security countermeasures in our networks. So first, you need to figure out where do you get your information from, and secondly, you need a method to actually get this information down to those devices that protect your network. So in an official definition, threat intelligence refers to researching the actual TTPs of the attacks. TTP stands for tactic, technique, and procedure, which is basically a way of saying how is that attack being conducted? How does an attack happen? And threat intelligence is all about researching these attack methods. So where do we get this information from? Now, of course, it would be great, nice, beautiful to have one single source of information, one single source of truth, a Wikipedia of, of all the security threats out there. Unfortunately, there's no such thing. But things don't actually look so glum. They actually are a lot of sources out there. You just have to select the right ones and to combine what is relevant for you, for your environment, for your network, for your use case. Not everything out there is going to be relevant. Even though it's relevant to security, it might not be relevant to your environment and to your needs. So let's see a couple of these sources that we can use to get more information, to research more about potential threats that we might be facing. Starting with, and in no particular order, because there cannot be an order in selecting these potential sources, starting with companies and universities. They usually publish white papers, they publish journals, they publish papers on specific threats or potential attack methods that can be performed or have been discovered and analyzed in the real world. And so it's basically a way of avoiding doing this research for yourself and reading the research already done by other people out there. Second, we have the darknet and the dark web. Well, the darknet and the dark web, actually the darknet is an overlay network on top of the internet, which can be accessed using the Tor network, the Onion Router network. You can download a Tor browser for free, and the content that is being hosted on this type of network is usually called the dark web. Now, this content of course, don't expect it to be indexed as nicely as you can just search for it on Google. You're not going to find this content. You have to know where the websites and where the content is actually located. So it has to be disseminated from person to person using bulletin boards, using feeds, using instant messaging, using any type of communication channel. But this is not the type of internet that can be easily searched. Well, why is that? Because a lot of the content in there is completely illegal. This is the place where you can buy things that I don't even want to think about. At the very least, you can buy cyber attacks. You can buy a denial of service attack for a specific target for a specific period of time for just a couple of dollars. And again, you can do a lot of nasty stuff in there. And I don't want to mention everything that can be done just so I don't get flagged by YouTube. But it's a place where anything goes. Now, why is this an important source of information for threat research? Well, because attacks are actually sold and disseminated over this dark web. Cyber attacks, exploits, new vulnerabilities that are being discovered, zero-day exploits are being monetized over this network in an attempt, of course, to gain money out of these exploits. Monitoring, researching what is being traded in this network can provide a useful insight as to what potential attacks you might expect in the future. Behavioral research is more on the lines of storytelling, so to say. It's basically a description of how an attack is being conducted, how it was observed in the wild, in the real life, and how you could probably attempt to protect from such an attack. Reputation sources, on the other hand, are much more useful because these are the actual feeds, lists of malicious or potentially malicious IP addresses, domain names that have been observed to host malware, to send spam, to generate denial of service attack, to act as command and control servers for denial of service attacks, and any kind of malicious behavior. And there are security researchers out there. In most cases, they belong to one of the major security vendors, Cisco, Fortinet, Palo Alto, Check Point, and so on, which actually maintain on a daily basis, on an hourly basis, these up-to-date lists of malicious destinations on the internet. Now, the good thing is that their devices, their firewalls, their next generation firewalls, can dynamically update these lists and implement them inside of their traffic filtering policies. So the moment a potential threat is being detected on the internet coming from a specific IP address or a specific domain name, you could actually be protected in a matter of seconds. And that domain name, that IP address, could be instantly added to a deny statement inside of your firewall, blocking any type of communication with that destination, thus protecting you and your network from any kind of exposure from that location. Of course, in some situations, you have to pay for this type of updates. Fortunately, there are also free and open source feeds that help you protect your network without actually breaking the piggy bank. Also on the topic of updates and dynamic updates, we have attack signatures. These are mostly used by intrusion prevention systems. Those are the devices or the software security solutions that deal with analyzing the actual traffic that comes into your network, looking for patterns that might indicate an attack going on inside of that traffic. Now, in order to be able to detect such an attack, of course, the IPS device needs to know how that attack looks like. And that attack is being described as an attack signature. It might be just a single packet with a specific sequence of bytes in it. It might be a sequence of packets. It might be a set of fragmented packets. There are tens, even hundreds of thousands of signatures out there that indicate attacks that have been observed to happen in real life. And just like with the reputation sources, you can get these for a fee or for free. Of course, they're not going to be the same content. You can expect usually these types of dynamically updatable feeds to have more up-to-date content if they come from a paid source. Next up, we have the cyber threat intelligence feeds, which are pretty much what we just talked about, right? Attack signatures, reputation sources, but these are more concerned with actual SIEM solutions, that is, security information event management solutions. These are complex solutions that attempt to gather events, whatever happens in your network, and try to correlate those events and understand what's going on in there. And their purpose is to be able to correlate potentially uninteresting events that, when analyzed together, might indicate a potential for an attack. For example, let's take this event. I, Andrew, have just connected over VPN from Romania to my company VPN server. All right, that's a completely legitimate event. Now, we also take another event that says I, Andrew, have just connected from Germany to the same company network. That's also a legitimate event. Now, what if those two events, which separate don't cause any concern, what if those two events happened in a time interval of 30 seconds? That's probably going to match a signature in that SIEM solution that says impossible travel time. It's impossible for me to connect using the same user account from two different countries over 30 seconds, which can raise a flag, can raise an alarm that potentially my account has been compromised. So that's one of the reasons why SIEM solutions are pretty expensive, because they're really smart and they can help you a lot. Now, just like we said before, most security vendors out there provide their own security updates. It might be antivirus signatures. It might be about intrusion prevention signatures. It might be potentially malicious URL lists or IP addresses. So these are vendor proprietary threat feeds, and in most cases, these threat feeds only work with their own devices, with their own security solutions. Now, I know people don't really like documentation, and they don't really like writing it, they don't really like reading it, but there's a whole lot of information in the official vendor documentation for your security solutions. So for example, let's say you buy a firewall from Check Point. You might just think that you're going to wing it, just install the firewall in there, just create some access lists, create some traffic policies, and there you're good to go. Well, there might be that Check Point has thought of writing a paper writing a guide, a security guide for actually hardening your network or hardening your firewalls. You might want to look into those guides because they might be addressing some potential attacks or exploits or vulnerabilities that you might not even know about. So they might have some security features that you could enable in those devices. You just have to know about them. So read the documentation. Another source of information are the ISACs. The ISAC stands for Information Sharing and Analysis Centers. Now, these are threat intelligence sources that are specifically maintained and developed for specific industries like oil, gas, aviation, power distribution, and so on. And they address the risks, security risks that these critical infrastructures might be facing. So this is probably going to be relevant to you only if you're working for such an industry provider, but these publications are in most cases free. So you could have a look over these in order to better understand what's going on in the security world, because they're mostly state-sponsored and they have a lot of resources dedicated into maintaining the information behind these ISACs. Here's an example of ISACs at nationalisacs.org. So it's a list of most of the ISACs in the world. For example, you can see we have some for aviation, communications, gas, elections infrastructure, not electronic infrastructure, elections actually, electricity as well, and they all have their own websites. Let's visit one of them. So this is the Electricity Information Sharing and Analysis Center. You can see right here. If you click on the About the ISAC, says the this one offers the electricity industry quality analysis and rapid sharing of security information on how to mitigate complex, evolving threats to the grid. Now, it sounds like Tron in here, but it's about the electric grid, right? Anyway, all this information is public, all this information is free. Have a look over them, or at least try to remember that they exist for the exam. Now, open source intelligence, as I said before, these are the security information sources that are being provided in an open manner. So you don't have to pay for the actual information, but in most cases, these are maintained by companies that make their money from consulting services, from actually providing you with help implementation services for your security infrastructure. But they provide you the threat information, they provide you the security information for free. Now, there are a lot of companies out there that do this. Just to give you a couple of examples, we have, for example, from Alien Vault OTX, that is the Open Threat Exchange. You can see here it provides you free access to over 19 million threat indicators daily. All right. Quickly identify if your endpoints have been compromised. Share your threat research. So you're probably going to have to, to share your own information if you want to use this. So you'll have to contribute back to the community. That would be the nice thing to do. And all this information is provided as a feed, so it can be automatically downloaded by your security devices and automatically implemented in your security policies. One interesting feature that we have in here is if you click on the browse, you're going to see a lot of the honeypots in here, which are basically intentionally left open services on the internet. For example, this is just an SSH server. Right? This is intentionally left open, which is monitored as to what kind of attacks are trying to hit it. And in which way is it getting hit? Is it being attacked by brute force attacks? Is it being exploited by specific vulnerabilities to basically gain access to the logs generated by these honeypots and the sources and the IP addresses that are generating these type of attacks, because these are actually the sources of potential attacks, of potential brute force attacks, of potential malware that can be easily then integrated into security feeds, which are then communicated to everyone who subscribes to that feed. Another one is the MISP project. Again, this one provides you with a lot of feeds available for free in different formats, depending on how you want to import this information into your environment. So for example, you have feeds for malware domains, you have Tor nodes if you don't want to allow access or traffic with potential dark net entities in your network. Let's see what else we have here. A lot of blacklists. IP blacklists, which were detected in the past as generating malware traffic or attacks. A lot of IP blacklists that have been detected in the past as sources for malicious content. I like this one right here, badguys.txt. right? There it is. This is the list of bad guys. How bad do they look? This list is actually huge, right? You can see it's actually a list of IP addresses sorted, right? But this is basically a list of all the IP addresses that have been involved in some sort of a malicious behavior. So it's as simple as this. You can see I can even download these lists without even authenticating or requesting access of any kind. Another one is the Spam House project, which, as you can probably guess from the name, is a project that tracks spam and related cyber threats, such as phishing, malware, botnet, so basically any kind of nasty thing that can arrive through an email message. And even though it's an open source project, you can see that they protect over 3 billion user mailboxes. We probably have to check this asterisk here. And these are responsible for blocking the vast majority of spam and malware sent out on the internet. Now, the mileage may vary, of course. Maybe there are not 3 billion users out there, but this is still a very useful and a priceless source of information if you want to fight spam. And another one that not many people know about, at least not from a security intelligence perspective, is VirusTotal. You probably know about this website, and you know that you can submit a file in here and get it scanned by 50 or something antivirus engines. What you might not know is that you can also submit a specific URL in order to detect malware or the reputation of that website, or you can even search by URL, IP addresses, domains, or even file hashes. So this is also a very strong security database of everything that is nasty out there on the internet. And by the way, they also have some paid services, which they've introduced quite recently, like the intelligence service and the threat hunting service as well. So that's it about open source intelligence. A lot of value when it comes to open source. Finally, we get all the rest, like papers, talks, recorded talks at security conferences, RFCs. The RFC stands for request for comment, and it's kind of a bad naming convention for the actual standards that have ended up as being the de facto standards that we currently use in networking and in protocols, applications nowadays. But there's a lot of information in there. There's a lot of information in those RFCs because those RFCs actually describe how a specific protocol should behave. Now, a thorough security analyst could potentially analyze such an RFC because it's at the end of the day is just a piece of documentation and find some flaws in it. Just by understanding how a specific protocol was designed to work can reveal some weaknesses in that design. So simply analyzing those RFCs can provide some useful security intelligence as well. And I don't need to tell you about blogs and social media, right? We all read those, hopefully. All right, so we briefly mentioned TTPs, tactics, techniques, and procedures before. Let's just put it in a more general context here. A TTP, a tactic, technique, and procedure, is a statement about how an attacker behaves. What's the tactic? What is the behavior? What is the technique that is being used to conduct an attack? And what is the actual procedure being followed in order to exploit the desired system? So when we're saying that we're performing security research, we're basically researching these tactics, techniques, and procedures. And another very important term here is IOC, indicator of compromise. An indicator of compromise, just like the name says, is some sort of a proof that we can find on a machine, on a system, even on a network perhaps, that proves that we have been breached. We have been the victim of an attack. We have been exploited. Now, of course, given the vast diversity of potential attacks out there, there's also a huge amount of proofs that we can look for. So IOCs can be a number of things. Let's see what are the potential IOCs that we can find in a network. Let's see what we're looking for when we're looking for proof of an attack. First of all, we could be looking at a malicious URL, and we should know that the URL is malicious now that we know that we have available a lot of threat intelligence sources, even for free. So there's no excuse. You should have some sort of system in place. You should have your devices configured to automatically detect and flag these URLs as potentially malicious URLs. Now, these URLs, of course, could be found in network logs, in web server logs, in proxy logs, or even in actual network traffic. If you manage to intercept the traffic that is actually going from the host to the internet, attempting to access, to connect to such a malicious website, you could break that connection from the very beginning. and perhaps even generate a security incident or security event in order to figure out what happened that made that host, that user, attempt to access a malicious destination. An IOC could be a new file appearing on a host. It could be a file that gets downloaded from a remote website. It could be an attachment from an email. It could be a file that gets added to the system files of the operating system. We could be looking for proof of execution of a certain process. If we know that we have a list of certain executable files, we might have an pre-approved list, like a whitelist, of all the allowed applications that can be run on a specific workstation in our company. Now, any kind of executable file, any kind of application that is attempted to be run outside of that approved list might raise some flags. An IOC or a proof of compromise can also be a running process inside of the memory of your hosts. If you have a well-defined and well-maintained network of hosts, you can probably expect that most of those hosts are going to be running the same processes, the same services. The moment a foreign process, a foreign service appears on one of your hosts, that could be a cause of concern. A RAT is a remote access tool or remote access Trojan. Well, this one is a nasty one because if you find such a remote access tool in your network, not only is this proof that you've been breached, so that malicious code has been installed and is running on some of your systems, but there's also a connection from that host to the attacker. A remote access tool or remote access Trojan is basically a tool that gets installed on a compromised host that in turn allows access to an attacker from the outside to control your machine. A file hash is a fingerprint that can be calculated from the contents of a file. It's usually a fixed size, but the idea is that whenever the contents of the file change, the hash automatically is going to change as well. Now, when is this useful? It is very useful for some tools that are called file integrity monitoring tools. These are tools that are designed to calculate the hashes of all the, let's say, legitimate files on a system, such as the files that belong to the operating system, Windows files, all right? Now, the moment when those Windows files start reporting different hashes from the ones that have been stored from the very beginning in that hash database of the file integrity monitoring tool, that might be a cause of concern. This might indicate that somebody else, a potential attacker, is attempting to change some system files, is attempting to replace operating system files with malicious versions. And now, of course, if you're thinking about, well, what if somebody just updates their Windows, right? Isn't that going to change the Windows files? Yes, it is going to change them, but usually the update process is tightly integrated with the file integrity monitoring tool. So this is an allowed process that actually updates the file hashes in turn as well. The Windows registry is a huge database of a lot of information which can potentially hide a lot of malicious content as well. There are tools out there that periodically scan the registry for malicious content or even scan the registry for any unexpected changes to the registry. This is one of the approaches to security that you're going to see quite often nowadays. Instead of looking for specific signatures of an attack, you're looking for abnormal behavior. You might not know exactly how an attack is going to look like, you might not have a signature for it, but you know that any change in some place that should not present any changes, it might be a cause of concern, like the Windows registry. Resource usage. This is another potential indicator of compromise. If you suddenly see a high resource usage on a CPU, memory consumption, disk I/O, input and output, disk usage, network bandwidth, it might be that, I don't know, a backup is happening on the network, which might be more than fine. But it also might prove that you're running some crypto mining software. Maybe you're running some crypto locker that is attempting to encrypt all your files on your hard drive. So a close monitor of the host resources is also a source of potential indicators of compromise. New applications detected on a system. This is very easy to detect and can be easily enforced using group policies in Windows as well. Any new application that your users need to install should be authorized, should be permitted by the IT department and by the security department first, of course. Network traffic might also be a source of indicators of compromise. That's simply because many attacks rely on the network to first get inside of your company network and then to propagate to their final destination. So just by looking at the traffic, you have the chance, theoretical chance, of catching that attack before it even happens. Now, one source of such indicators of compromise is by monitoring the network traffic and looking for protocols that you know should not be present in your network. New devices connected either to your hosts, your endpoints, or to the network. You probably should have some sort of centralized IP address management system or a tight control over the DHCP servers in your network in order to detect whenever a new endpoint is connected to the network. Now, of course, not every new device is a threat to the network. It might be just an accidental insider threat, as we just talked about in the previous video. It might be that somebody brought a smart device from home and they just decided to plug it into some free wall socket. And finally, exfiltration, data exfiltration, which is another word for data theft, stealing files from inside of a company. That's also a cause of concern, especially because it can be prevented and it can be detected. If you're looking at the traffic that is leaving your company and you're looking at any file uploads, you're looking at any kind of, perhaps even VPN tunnels that are being established from within your network to the outside world, you could potentially catch those files before they actually leave the company premises and prevent data exfiltration of sensitive information. All right, so we have a lot of things to look out for, so many things to monitor, and you might be thinking at this point, well, this is a full-time job for, not for a person, but for an army. How do we actually make this happen? How can we navigate this huge amount of information and actually make sense of it and in real time so that we don't catch a threat 6 months after it happened? Well, we have a lot of things to look for because malware can be extremely complex, right? So we need to change our way of thinking about malware. And while we look for IOCs, let's see some of the things to keep in mind. Well, first, while you could manually inspect all those IOC that we talked about, you'll get much better performance, get much better visibility, and well, you'll analyze much more information if you use a dedicated automated tool for this. You'll find tools like these under the names of HIPS or HITS. This is host-based intrusion prevention or host-based intrusion detection. The difference being that the detection part only alerts or reports, and the prevention part actually blocks the threat. You can also find these under the name of endpoint security suites from a lot of vendors out there. Now, those are usually the pieces of software that make your computer run crappy just because it's secure. Secondly, sometimes a single IOC is not enough to prove that a host has been compromised, because one single anomaly might be open to interpretation, or might not even raise any alarms, but correlating multiple IOCs can show a pattern. This is also one of the reasons why for some attacks we simply cannot create static signatures to detect them. And we also have dedicated appliances and solutions for this. We call them SIEMs, or Security Information Event Managers, and we're going to talk about them in a later video. And finally, third, we still have the problem of identifying each individual IOC and deciding if it's good or bad. Computers create files, processes, network traffic, network connections all the time. Sometimes they generate thousands of events every single second, and not to mention that in large companies you have thousands of endpoints running at any given point in time. So not every event is also a security event. There's a lot of effort involved in this triage phase. And by the way, since we're here, let's introduce one more term, and that is threat modeling. So we have so much information about attacks, about reputation, malware signatures, attack signatures, IOCs. All of this is part of one big concept called threat modeling. So describing all this information is actually modeling this information related to threats. So that's what threat modeling is all about. So here's another challenge for us. How do we describe all this information in a meaningful and consistent way? How do we write this stuff down, leave this wisdom behind, and not just leave it behind, but actually inject it, import it into the actual security devices that can make use of it? So for describing, storing, and sharing threat information, we have something of a language called STIX and a protocol called TAXII. Well, at least they're easy to remember. Starting with STIX. Well, STIX is one of the standard ways of describing those IOC findings and the relationships between them. Now, STIX stands for Structured Threat Information Expression. And right now, the current version of STIX is version 2, based on JSON. Version 1 was based on XML, so make sure you remember the difference, just in case the exam asks you about it. Now, the structure of STIX, of course, is not arbitrary. It's a standard after all, and it's made up of SDOs. This is a STIX domain object. You just have to know about them. You don't need to memorize them. So these SDOs can be, just to quickly review them, they can be about observed data, like an IP address, a file, something that would be detected and recorded by some monitoring system, an URL or something like this. An indicator is a pattern of observable that can be identified and might be relevant to cybersecurity. So not every observed data is an indicator. When an observed data becomes an indicator, it's something that has gained a higher level of concern from a security perspective. We also have attack patterns. These are the known behaviors of an attacker, or the TTPs that we just talked about. And again, this is one way of saying if this is happening to your network, then you're most likely the victim of an attack. We also have the threat actors and the campaigns that those threat actors might be a part of. These are the adversaries that are launching the attacks, along with the scope of the attack. Now, the scope refers to, it might just be you, the one being targeted, your company, or your person, or your device, or it might be multiple organizations all over the world, in which case we'll call it a campaign. And a course of action, or a COA, well, that's the mitigation technique. What can you do in order to resolve that threat? Or after the attack has happened, what can you do to minimize the damage from that security incident? So for example, if we decided to determine how we can describe a malicious URL using the STIX language, we could head over right here, right, and click on this indicator for malicious URL. And this is a way of describing us how the data model is supposed to look like, and also an implementation. For example, in JSON, this one is going to look something like this. Now, if you look in the object section, we can see that the first object is of type indicator, and this is the actual pattern that we're looking for to indicate to us that we are looking at a malicious URL, right? So this is the malicious URL right here. You can see a name and a description for it, when it was created, a specific ID for this indicator, right? So this is how we mark this URL as being a host for malicious content. Now we can also enrich this information even further with another type of object. This one is of type malware, which actually describes the actual malware that is being hosted at that website. Again, this one has a specific ID, right? The malware type, in this case, is a backdoor or remote access Trojan, which is pretty much the same thing actually. And then we have some phases from the kill chain. Then we see a description of this malware. This malware attempts to download remote files after establishing a foothold as a backdoor. So this is the generic behavior of this type of malware. And finally, we have another type of object, and this is the relationship between, well, the indicator, that's the URL that we just talked about, and the malware that we just described up above, right here. So this is one way of encompassing all this information into a single file. And being a JSON file, this can be easily processed by machine, by additional security software, and can be interpreted and instantly implemented into a security policy so that you immediately get protection from this URL as well as from any malware that is identified as being this type of backdoor. So this is how STIX works. And well, all is good. We have some way of describing malware and malicious content and potential threats. We also need a way to disseminate this information, to communicate this information from machine to machine. Because, well, that JSON file we just saw was not meant for human eyes. I mean, we can read it, but you're not going to be the one actually blocking the traffic that goes to that malicious website, all right? You do have to implement this into an actual security software solution. So there's also a protocol that we're using in order to disseminate this type of information to our actual security devices. And we have two methods of doing this. First, we have the not so obviously named collection method, which is a way in which clients connect to the servers and actually request this information, request the description of these potential indicators of compromise. Second method is called the channel, where the producer of this information stores it on a server, the clients subscribe to that server, and then the server in turn pushes this information whenever new updates come in to all the subscribers. So make sure you understand the difference between these two. The exam might ask you about this. Well, if you thought that we're done with all the threat information sources that we need to cover, well, we are not done. This presentation is all about information overload. So there's just so many places out there, so many sources of information that can help you out in securing your network. So honestly, there's no excuse nowadays in just to not use this information in order to better increase your security posture. So let's talk about a couple more of these. One of them is AIS. This is Automatic Indicator Sharing. This one is offered by the Department of Homeland Security, and it's destined for those ISACs that we just talked about. And by the way, it also uses STIX and TAXII. The threat maps are actual maps of the world, perhaps, that are revealing, most likely in real time or close to real time, the actual attacks that are happening all over the world. You might have seen this in news reports, you might have seen this in dashboards, and I'm going to show you a couple of them right now. Now here's one from Fortinet, which kind of looks like a computer game where your nations are, shooting at each other. They're not actually shooting, but they're launching exploits and well-recognized attacks. You can see that the United States is currently under attack from from Europe, a lot of countries in Europe. That's probably just an exception happening right now. You can also see the list of actual attacks scrolling by right here at the bottom. So we see attacks attempting vulnerabilities in Microsoft Office, Oracle database, VLC, IIS, Zendesk, interesting one, and so on and so forth. Microsoft Internet Explorer, nobody is surprised by that one, maybe, I guess. So a lot of shooting around happening in this threat map right here from Fortinet. We could also head over to another one from Checkpoint, another map of countries shooting at each other. This one this time is between India and the United States, apparently at this very moment. Again, you're gonna find a lot of statistics in here, so it's not just a pretty website with some HTML animations in here. There's actually a lot of information behind all this, all these pretty animations that you're seeing right here. FireEye also has a similar threat map, and again we can see countries shooting at each other. Let's see in full screen here if we can see more information. We have top 5 reported industries under attack. So financial services apparently are the number 1 under attack right now. I believe there should be, yeah, right here. There's the attacks today, 500,000 attacks today. I don't know when today started actually for this website, but there's a lot happening out there. So a lot more, a lot more reasons to actually consider these threat intelligence sources. This is just how many attacks are happening each and every second all over the world. And these are all the attacks that we know about. There's a lot of zero-day exploits that we don't know anything about that are being conducted without anybody noticing, perhaps. So these are the threat maps. Nice to look at, spectacular if you put them up on a dashboard, but there's also real information behind those attacks. And finally, we have file and signature databases. File databases are basically referring to malicious file databases, or as you can see in the latest developments, especially from companies such as Cisco, we do see the emergence of solutions that actually store hash values of all the files being detected in networks all over the world. That is because if you have such a database of file hashes, you can basically replace all the antivirus scanning effort with just a file hash of that file, ask the cloud service about that hash, which is just a smaller request containing just a file hash, and the cloud service is going to tell you, I have seen this file before, I have scanned it, it's clean, or I have seen this file before, I know it's malicious, make sure you block it before it reaches further into your network. So nowadays we don't just have signatures and hashes for malicious files, we also have signatures and hashes for valid and clean files. And signature databases, right? When you see a signature database, think about 2 things. Think about antivirus and think about IPS. So either you're looking for a malware signature in a file, or you're looking for a traffic signature in some network traffic. And finally, we have a lot of information in vulnerability databases. Vulnerability databases are databases of known and discovered vulnerabilities. You might be thinking, well, if the vulnerabilities have been discovered, then they're probably already fixed, right? Why do we care about them anymore? Isn't that funny? No, unfortunately, people don't install updates that often, apparently. And we're not just talking about Windows, Mac OS, and Linux devices, but think about your smart TV at home. Think about your home wireless router. Think about your smart light bulbs in your house, perhaps. Think about all the internet-connected devices that we currently have on our bodies, in our homes, in our offices, in our cars. Do you update them all? Sometimes you don't even have access to an update interface in order to update the firmware and to fix those vulnerabilities that have been discovered on those devices. So just the fact that a vulnerability has been discovered and documented doesn't mean everybody is protected against it. But it does mean that if we detect a specific piece of software running a specific version of that software, and we correlate this with a vulnerability database that says that specific version is vulnerable to this and this attack, well, that is actual usable information, security intelligence that allows us to determine that we are now exposed to a specific security risk. And the first stop, one of the first stops for such vulnerability databases is the cve.mitre.org website. Or you can just search here for a specific CVE. By the way, CVE stands for Common Vulnerabilities and Exposures. Basically, just saying vulnerabilities, right? So let's search for, I don't know, let's assume that we have an ASUS router in our home. Well, if you do have an ASUS router in your home, you better start praying right now. This is how many vulnerabilities were found in the ASUS firmware in the last year. Did you expect to see that many? Well, if you did, congratulations, you're a well-informed security professional. If you did not, well, I have bad news for you. This is how bad it is when it comes to vulnerabilities in the public domain. And of course, you can get more information about each and every one of these vulnerabilities. So for example, let's say if you're selecting this one here, insufficient filtering for special characters in the HTTP header parameters. So an attacker with general user privilege can exploit this vulnerability to inject JavaScript code and perform a cross-site scripting attack, right? So let's see more about this one here. I'm gonna get some links, some references, and let's head over to the National Vulnerability Database. That's nvd.nest.gov. You can see it's the exact same code, the same vulnerability code right here. Have a base score of 5.4, which is a medium type of vulnerability. Now this score is calculated from multiple metrics that impact the actual device or the attack method, like how easy this exploit is to be conducted, how dangerous it is, how much does it actually expose, or what kind of privileges are required by the attacker to actually conduct this type of exploit. Now, it's not a critical exploit, but it's still one that might cause you some concern, especially when you find attacks that require a low attack complexity, like this one, with low privileges. So this is kind of like a low-hanging fruit for attackers, right? They don't need much to conduct this type of attack. Fortunately, for this type of vulnerability, the confidentiality, the integrity, and the availability impact are pretty low or even non-existent. So this is probably the reason why the score isn't that high, actually. So it's just a 5 on a scale from 1 to 10. Well, what's next in threat detection? Well, as you know, we're pretty much throwing AI and machine learning now to every product on the market, so why not do it for security intelligence as well? So of course, next in threat detection is artificial intelligence and machine learning. And the reason behind this approach is the fact that we need to improve greatly on the decision process. We're seeing something in the network, we're seeing something happening, we're seeing a file being transferred, we're seeing a domain, an IP address being accessed, we're seeing some sort of a user behavior. We need to define, detect, decide whether that behavior is malicious or not, even in a situation where we don't have a specific signature for that type of behavior. That's where machine learning helps us a lot. And I'm not going to say machine learning and artificial intelligence because we're not there just yet. We still don't have AI. What we really have is just a glorified machine learning. And this is one thing that starts being found and implemented by a lot of in a lot of security solutions out there, by a lot of security vendors, which is a good thing because it can help you a lot with filtering a huge amount of information, a huge amount of event data that normally would be impossible for a human being to process. But it's also extremely prone to error because a machine learning system, a neural network behind that machine learning system needs to be educated, needs to be trained with actual data. You need to explain to it what does a legitimate behavior look like so that it can decide when something goes outside of the norm, when something goes outside of that baseline, why that thing might be a cause for concern. So there's a lot of work in here. Fortunately, with all that information that we have available at our disposal nowadays, especially with the open source intelligence and all the information sources that we talked about, we can dump all that information into those machine learning algorithms and teach them from those static signatures, from those observables, IOCs that we know about, what's good and what's bad. And also on the same line, pretty much with machine learning, we also have prediction-based analysis. This is one way of saying, well, ideally, we would like to be able to prevent an attack before it even begins to manifest itself. How can we do this? Well, for example, by monitoring the dark web chatter. Well, if we see a concern for a specific target, if we see a specific type of attack being traded, being discussed about a specific target, about a specific company, then if we have an automated system that is able to understand this type of traffic, this type of chatter, we might one day be able to actually block an attack before the attacker even decides to perform it. Now, if this sounds like science fiction to you, don't worry. It does sound like science fiction to me as well. Alright, so that's it about threat intelligence. A lot of useful content in here, and I hope a lot of interesting content. If you want to know more, if you want to talk more about this, leave a comment. And if you enjoyed this, like and subscribe. Good luck on the exam, and see you on the next video. Bye bye.